Welcome back to Miss Letter's Calculation Station, where things add up. This is the Chapter 9 Test Review, Part 2. Number 7, use the mortality table to answer the following questions. There is a blank percent chance a 66-year-old man dying before his next birthday. So 66, we're just going to move that decimal over twice to the right, add a percent sign. So 1.9564%. Hope I grabbed all those numbers correctly. Part B, if the insurance company insures 10,000 63-year-old males, how many are expected to die? Well, here's the death probability. So we are looking at 10,000 times 0.015312. 10,000 times 0.015312. And we're looking about 153. Now we can't have a 0.12 male, so we're just going to round it to a whole number. So 153 are expected to die. Based on the table, what's the probability that a 63-year-old male will live? So if the probability that he's going to die is 1.5312%, then the probability he would live would be the complement. Hopefully I got those numbers in there correctly, 1.5312. So we're looking at a 98.5% probability that he's going to live. I think he's got pretty good odds there. Number 8. All right, so Deanna's 33. She's going to retire in 30 years. Excellent. She's going to put in $420 every month. And she's calculated that her final working salary is going to be $94,000 a year. She's been told by her financial advisor that she should have 65% of her final year annual salary available for use each year when she retires. What is the income the financial advisor feels she must have every year? Well, $94,000 times 65%. Remember that we do not have a percent button on here, so convert that percent to a decimal. So we're looking at $61,100. It's more than I make. Use the balance formula. We already went over the balance formula on here. Just make sure that when you're putting in time on these, that T is 60 minus 33. T is 61 minus 33. T is 62 minus 33. So that when you do it, and then I'll do one and show you how quick and easy it is. So we have the alpha y equals, she's going to put in 420 parentheses 1 plus alpha y equals. We have the rate of 0.0225 monthly raised to the n. And here's what you could do with the t. You could literally just put in 60 minus 33 in parentheses. And that way all you have to do is highlight it and change the 60, 61, and 62, and you're not redoing every single one of these. Alpha y equals, and we have the 0.0225 over 12. And like I said, all you have to do is just scroll up, hit enter, once again, twice. Same things. Oops. It helps if you change the time to 61. Scroll up, enter. Same thing. You're going to want to scroll up and over and change this to 62. So just a little shortcut when you have multiples of the same one. So let's go back and let's see here. Age of 60, we're looking at $168,294.09. $176,703.07. And last but not least, we have 185,000. It's hard to read that without commas. Okay, so I was just made aware of an error where we put the R as 0.0225, and then in the denominator I put 0.025. Simple mistake, easy to fix. We could just go right back up here, change this to 0.0225, and I'm just going to go backwards now. So I'm going to do the 62, go back up, change that to 61. It's really nice with these calculators that you can just easily go back through and highlight, hit enter, and just fix them when it's just a small error in 60. So now I'm just going to go back up, and we have $186,993.43. $196,336.75. And the last but not least, for the age of 62, we have $205,892.47. Make sure that you are rounding to the nearest penny. And thank you, Rigo, for pointing that out. That could have been disastrous. Assume that Deanna is planning on using 60% of her current salary in each of her first 5 years of retirement. What should her annual amount be? So we have 94,000 times 60%. And that gives us $56,400. All right, Mitch opened a retirement account. Annual yield 4.2%. He's planning on retiring. How much did he deposit so that he has $1 million by the time that he retires? So we want to know how much did he put in. So that is the put in formula. So we want $1 million. So we want to know how much to put in. So how much to put in or deposit every month. And I'm going to use this formula right here. And I want $1 million. Look at all those zeros. Parentheses, rate. Take away the percent sign with the decimal over twice to the left. Over N, the annual yield. I think it's annual. Sorry about that. That's a 1, not a 12. Helps if we learn to read. Raised to, or all over, 1 plus R over N to the NT. And we're looking at 13 years minus 1. Alpha Y equals 1 million, parentheses, alpha Y equals 0.042. Kind of threw me for a loop because everything we've done so far has been compounded monthly. So I was a little shocked to hear an annual compounding once a year. Raised to the 1 times 16. Don't forget that -1 that's hidden